Here are solutions to homework set number 6 for ECE 476-676 Advanced Embedded. This homework set looks at using the math, random, and matrix routines in Python. Now at the end of this assignment, we're going to look at building a flickering candle. So these are different random distributions for the brightness and duration. Here the brightness is a uniform distribution. The duration or sampling rate is fixed 100 milliseconds. This is a uniform distribution for the brightness, exponential distribution for the sampling rate, normal distribution for the brightness, constant 100 milliseconds for the sampling rate, normal distribution for the brightness, exponential distribution for the sampling rate. With that, I can build a flickering candle. Now the first problem is, here's a circuit. Find the voltages using voltage nodes and matrix math. So going back to circuits, the approach is, I've got 4 nodes. I need 4 equations for 4 unknowns. Node 0 is easy. V0 equals 10. At node 1, the current left, current down, current right all add to 0. So V1 minus V0 over 3 plus V1 over 25 plus V1 minus V2 over 4 equals 0. Likewise at node 2, the current left, down, and right equals 0. Node 3, current left and down equals 0. 4 equations, 4 unknowns. To solve, I group the terms, put this in matrix form, and then in MATLAB, I can solve. Well, for this assignment, I actually want to use Python. So the Python routines use the matrix routine. There's NumPy, that's the matrix routine for Python. But unfortunately, that doesn't work in MicroPython because it takes up too much space. But on Bison Academy, there's other matrix routines. So if I import the matrix routines for Bison Academy, I can now use them. I'll call this matrix B, call this matrix A, and the voltage is the inverse of B times A. The way that works is I first input matrix B, input matrix A as a 2x2 matrix, print B, print A, find the inverse of B, find the inverse of B times A, that's the voltage. Then display the voltage. So here's the B matrix, A matrix, inverse of B times A. This is your B0, B1, B2, and B3. Solve using matrix math in Python. To check your answer, I could throw that in MATLAB. MATLAB actually is a matrix language, works much easier. So here's your B matrix, A, inverse B times A, same answer. If I'm dealing with matrices, I would rather use MATLAB rather than Python. But if you have a Pi Pico and you need to do some math, you can sort of do matrices. It's kind of a kludge, but it works. Problem 3 looks at making a candle flicker. Next, the next problems look at random processes, some statistics, and a candle flicker. I want to make a candle flicker where the on time and the brightness is a random variable. The first part is make sure that I can turn on and off the LED using an H-bridge, or actually I used a transistor. So here's a transistor, turns on and off the LED, controlled by the Pico. I could check that. Here's the control pin. If I connect that to 3.3 volts, on, ground is off. So at that point, I'm convinced the transistor works. I can turn the LED on and off to make it flicker. If I can vary the brightness, I'm just going to make it get brighter, dimmer, bring the duty cycle. Problem 4 is now let's use some random processes. Use the random library in Python. And this actually uses quite a few libraries. I want to have an LED where the brightness varies between 0 to 100%, and I change the brightness every 100 milliseconds. Now, one way to do that is X is the brightness, Y is the sampling rate. I'll pick a random variable between 0 and 65,000, set that to the brightness, set the wait time, the sampling rate to 100 milliseconds, and here's what that looks like. In my opinion, that's not quite a random candle flicker, but that's what this algorithm looks like. What if I change that? Well, if I make x be a uniform distribution between 0 and 100, so there's x, let y be an exponential distribution with the mean of 100 milliseconds. So to do that, I take the log of a random number times 100, and here I got the parentheses in the wrong spot. Here's the actual code, log of a random number between 0 and 1, minus that, times 100. That gives an exponential distribution with the mean of 100 milliseconds. If I switch over to that one, it's kind of showing up using the touchscreen. That's what this looks like. Yeah, maybe a little bit better. Another version. Let's have x be a normal distribution, y be fixed 100 milliseconds. What's that look like? Well, to do that, I'm going to create a subroutine called RENDN. That just adds 12 uniform distributions, subtract 6. The result has a mean of 0, variance of 1. Kind of looks like a normal distribution. If I go over and select that option, the brightness is normally distributed, and the sampling rate is fixed 100 milliseconds. And to me, that actually looks like a candle flicker. Just for fun, let's have a normal distribution for the brightness and an exponential distribution for the duration. So if the duration is exponential with the mean of 100 milliseconds, that's what this looks like. Yeah, maybe even a little bit better. So with that, I can build a flickering candle with a Raspberry Pi Pico. The bonus part was add the touchscreen. That's kind of what I did here. I can select which program I want to run with the touchscreen. And the way that works is I check to see if I'm touching the screen. If I am, I don't care about the y coordinate. Just take the x coordinate divided by 100. So there's 0 to 100, 200, 300, 400. The x coordinate is what tells you which mode you're in. I will draw a black box. There's actually 4 black boxes, 1 white box around mode I. So here's mode is 0, 1, 2, 3, 4, ignore 4. Then in the main routine, it kind of does the different parts. If I'm in mode 0, here's the brightness, duration, mode 1, mode 2, mode 3, which wasn't asked for, but I did it anyway. And then you have the touchscreen switching between the different types of candles. So this one is uniform distribution, 100 millisecond sampling rate. What this one was. Uniform distribution, exponential distribution for the sampling rate, normal distribution for the brightness, fixed sampling rate, normal distribution, exponential sampling rate. And that is homework set number 6 for 476.